So here's how that data looks in Excel. Um, Here's the forage yield, which was declining over time. Here's the timber yield, which was increasing over time. This timber section where we calculate the SCV is no different than what we've done before. We take the yields, we multiply them times the price, which is in E2. So we have $15 a ton as our starting price. We calculate the NPV, and the NPV is the present value of the revenue. So revenue discounted back by however many years we are from the starting point, and we subtract off this planting cost, which is sitting in E3. So this column is the NPV, and we plug the NPVs into Formula 4 to get the SCVs. So based on the timber yields and the prices and the discount rate we're using here, which is 5%, it looks like the optimal rotation for trees is 22, and we have an SCV of $490 at 5%. For forage, things are a little bit more complicated. Remember when we were looking at the timeline, what's going to be true of all of these continuous benefits is we're going to have a cumulative NPV column, so it's sitting here. But let's work out how we got there. So here's the forage yields that were on the graph. It turns out to value forage, if you're leasing out the pasture for people to run cattle, is based on how much forage you produce, but it also has to be converted into a standard that's used in agriculture, which is animal unit months. So it turns out an animal unit month is how much forage a 1,000-pound cow-calf pair would consume in a month, which turns out to be 780 dry pounds of forage. So we convert forage into animal unit months because that's what lease rates are based off of. Here's the cumulative animal unit months over time. That's the green line on the graph we looked at earlier. We don't really need it for our calculations. It was just calculated here to put on the yield graph. The revenue of forage has two factors. It's the animal unit months, which is G11, times E5, which is the forage utilization factor. So it turns out you're only going to be able to charge for the forage that gets into the cattle because that's where the revenue is generated. And obviously, if you let the cattle eat all the forage, they would eat it down to the nub, and there would be no regeneration of the forage. So you don't allow that. And plus, they step on some of the forage, and they pee and poop on the forage, and all of that leads to some significant degrade between what you're growing and what ends up in the cow. Here we're using a utilization factor of 50%, which I think is standard in the stuff I've read. So the revenue is the yield times utilization factor times our lease rate on animal unit months. And so in this case, our lease rate is in E4, and it's set at $15 per animal unit month per year. So revenue forage has a little bit of conversion from pounds to animal units times the utilization factor times price, but in the end, we convert the yields into a revenue over time. NPV is the same idea. In year 2, we got $17 in revenue from forage. That's 2 years away, so we discount that revenue back by the interest rate by 2 years. And so the present value of $17.78 2 years from now with a 5% interest rate is $16.13. Year 3, we get that revenue 3 years out. And so this is the standard NPV calculation we've done up until this point. The next column is the additional column that we have to deal with, which recognizes the fact that if, say, we're at year 5, at year 5, that much forage was produced, which produced about $18 in revenue. That $18 in revenue has a present value of $14. But at year 5, we also got the income from last year's forage and the previous year's forage and year 2's forage. And we'll assume that the first couple of years we didn't run cattle because the trees were so small that the cattle probably would have eaten them. So, so when we're looking at the NPV for any continuous benefit, including something like forage that has an annual benefit, if we're at year 6, we want the NPV at year 6 to represent the present value of all of the forage we received up until year 6. So this $85 is the sum from J11 to J15, so it's all of those. And you can notice on the sum formula, I've got it locked to always start at 11, but the row in the second part of the sum is not locked. So as I drag that formula down, it's summing to whatever line we're at, which is exactly what we want to happen. So now we have the cumulative NPV of forage, which reflects at this point in time, here's the present value of all the forage we've received each year up until this. And if we're going to harvest the trees at age 7 and repeat that over and over again, each repeat of that 7-year cycle, we're going to assume that we're going to get this same stream of benefits. So what we want to repeat in our SEV is this cumulative NPV. So we have the cumulative NPV. We plug that into the SEV formula the same way we've done before. The NPV calculation is different for continuous benefits, but since it includes the accumulated benefit through time, we plug it into the SEV formula the same as before. So this is just formula 4 the same way it is over here. It's just as coming off of this cumulative NPV. So that gives us the SEV for forage, which is what's our present value from the forage part of this agroforestry system through time if we repeat this cycle every, in this case, 11 years. And as it turns out, we would choose, from looking just at the forage income, we would choose to harvest the trees at age 11. Right? And if you go back and look at the yield curve, that should make some sense, because age 11 is when we move from the high forage production to some significant shading effects, and we move there to lower forage production. So that makes some intuitive sense. Okay, so now we've got an SCB calculated for forage, and the forage production is tied to what's happening to trees. We've got a SCV calculation from trees, which is the same as it was before. So how do we put those things together? It's actually pretty easy. Over here, I've just copied the SCV column for forage and the SCV column for timber into this place so that they're right next to each other. You can see highlighted, here's the $490 from the timber SEV, same as over here, which is maximized at age 22. Here's the SEV forage, which is the same number as that, maximized at 11. And here's the total of those two numbers. So this column, the formula of this column is just SEV forage plus SEV timber. So that's all of the total present value income of repeating that cycle for both products through time. And it peaks at year 20. So our intuition with these numbers, these values and cost, is correct, that if compared to thinking only about trees, if we think about the forage value as well, we do compromise and harvest the trees 2 years sooner. And you're thinking, well, what's happening here? In other words, there's a big drop from 22 to 21 to 20, and remember that's this place in the yield curve here. So it's really a sampling error problem. If we were using smooth data, we'd probably have a 1-year jump rather than a 2-year jump. So if we look at what's happening on the SEVs from this, in other words, the graph we're going to look at now is graphing these SEVs through time. Here's what we've got. Here's the timber SEV, peaks out about $500 or so. Here's the forage SEV. It peaks out $400 or so. You combine those, which is simply adding this line to that line, and you get this blue line. And so this is the combined SEV. And there's a couple things to note. One is um, the timber values have slightly more weight in this, but it turns out the reason we don't compromise so much with forage is it's pretty insensitive to the year we harvest. In other words, if we miss the optimal rotation, which is 11, by 4 years either direction, in other words, if we go from here to 15 or back to 8, we're really not losing much money. So the fact that this curve is fairly flat and this one is much more sensitive to time means that when you add that flat curve to the timber curve, you're biased toward the timber optimum because it's not really worth giving up a few years on timber because it costs you a lot more than you gain from forage. And another thing to note is actually this combined SE fee is pretty flat in this region, right? We found that it peaks right here at $807. But if we were over here, we'd be at 780. If we were over here, we're at 756. So within this range, we have the ability to play the market. In other words, prices would be bouncing around year to year once we get to this point in the rotation. And since there's not much trade-off in terms of what's happening to the SEV value, we can just choose the year to harvest in here, probably based on what's happening to prices in the market, and take advantage of that, which is a good thing. So let's go back to the data curve and look at the sensitivity of this. One thing that we should expect is that the timber SCV, or the optimal rotation for timber, is going to be more sensitive to the interest rate than forage. Forage is a continuous benefit through time. It's an annual crop. You get benefits up front, spread through time. Timber has all the benefits loaded toward the end of the timeline, which makes the benefits sensitive to interest rates. So if I increase the interest rate from 5% to 8%, we can see that our optimal timber rotation goes down to 20. Our forage rotation doesn't really change. It stays at about the same place. And what happens is we've now made everything somewhat less valuable. The forage rotation is still 11. SEV timber is at 20. But the combined rotation is also at 20. So let's look at these curves. And what we've done is the higher interest rate sort of flattens both of these curves. And what we've done is move the combined total back to 19 because these values out in the future are discounted more. So that matches our intuition. I'll change this to 4%. We started with 5%. And it turns out at 4%, where we're not penalizing trees very much, the optimal combined rotation is the timber rotation. So the timber values benefit from, are helped more by the low interest rate, and the shape of the timber curve makes it not worth trading off for grazing. If we plug in a much higher forage value, so let's say 40 for forage, we can see that as you'd expect, the higher the value of forage, now we're getting somewhere in the range of $600 or $700 value from timber. We're getting twice as much value from forage, but given the flat shape of the forage curve, we're still only going to give up 2 years of the timber rotation for forage. So hopefully this gets you started, and when you think about doing the problem set on this material for the continuous benefits, the thing to understand is that once you get to the revenue and NPV calculations, things aren't really changing that much. But before you go from the NPV for this rotation to the repeat of that rotation in SEV, you need to include all of the values up until the time you're talking about, not just the values in that year. So hopefully this gets you started on the combined optimal rotation.